In this video we're going to look at analysing distance time graphs and what we can learn from them about an object's journey. Okay, so here is the distance time graph that we're going to look at. As you can see, time is on the x-axis down the bottom and distance is on the y-axis at the side. So this graph shows how over a period of time the distance moved by an object changes, and we can see that it starts moving further and further away. There's a period where the distance doesn't change, it remains 60, and then the object starts moving again and the distance travelled increases up to the time 100 seconds and a distance of 80 meters. Okay, so immediately I can work out that in 100 seconds this object has travelled 80 meters. The second thing we're going to look at now is what all the different features of this graph can tell us about this object's journey. The object starts its journey down at the bottom here at time 0. It then starts to move and the distance travelled increases at a constant rate. It's a straight line all the way up until here. Okay, where it starts to curve off. If we have a straight line in any section of the graph, so this is a straight line, it indicates that the speed of the object is constant. It's changing distance, it's increasing its distance at a constant rate. Following on from that, we can also have a horizontal straight line. So this section of the graph here is completely horizontal and it's also a straight line. So the straight line tells us that it's travelling at a constant speed. The fact that it's horizontal tells us that the object is stationary. Throughout this period of time, the distance, 60 meters, is not changing. It's staying at 60 meters. It's not travelling at all, completely stationary, so the speed is 0. If we have a section of the graph that's a curve, it tells us that the object is changing speed. So this section of the graph here is a slight curve. It's magnified in this circle here. We can see that it's gradually increasing in gradient. It's curving upwards. That upwards curve tells us that the object's speed is changing. Because it's an upwards curve, we know that it's getting faster, it's accelerating. It's changing distance at an increasing rate. We're going to have a look at another section of the graph here. In this part of the graph there's a very slight curve, and this curve is different to the other curve that we had before. It's a flattening curve. It's curving towards a horizontal straight line. Before we had an upwards curve, so it's increasing in gradient here, the gradient's reducing, it's getting flatter. If our curve is, as this one is, getting flatter, it means the object is decelerating, it's getting slower, it's moving towards a period of being stationary, not moving at all. The last thing that we're able to do from our distance time graph is work out the speed of an object. So we're going to work out the speed of the object in this first section of the graph, in this first 40 seconds, so between 0 and 40, where it travels 60 meters. Okay? To do that, we work out the gradient. Our formula for speed, if we remember from earlier, is distance divided by time. So I'm going to look across. The time is going to be 40, and the distance, I look up at my graph in those 40 seconds, it travelled 60 meters. So my speed of the object is the distance the object's travelled. It travelled 60 meters, and it did that in 40 seconds. So my speed is 1.5 meters per second. That's my unit.